Hey guys, I just wanted to start this off by telling you that I am going to be trying to blend some technologies here. Hopefully writing on the iPad will make my handwriting a little bit better than if I'm trying to write with a mouse, but if not, we'll see. I'll do my best. Toss me back into the bottom corner there. I have found with these problem-solving lessons that it's easiest to just work through some problems together to hopefully get you an idea as to what's expected when it comes to the practice. You do have 4 practice problems for this one, and I did try to give you guys hints on those to try and answer questions that I'm anticipating might come up. So let's start by just taking a look at this first one here. We're going to try and make some organized lists. That's the whole point of this strategy. Sebastian has 0.24 of a dollar, so 0 and 24 hundredths of a dollar. How many different combinations of coins can he have? So we're going to start by answering our standard questions for any kind of problem solving. What do we know? What are the facts? And the facts are simply that Sebastian has 0.24 of a dollar. And then we are trying to find the number of possible coin combinations. Now, if we follow down here, as we make a list, we know that we need to equal 24 cents. So the different ways we can equal 24 cents. Start off with our coins. Remember, a quarter is 25 cents. So we cannot have any quarters. We're only going to have dimes, nickels, and pennies. Dimes being worth 10 cents, nickels being worth 5 cents, and pennies being worth 4 cents. So we've got 2 dimes and 4 pennies. So 20 and then 4. 2 nickels equals a dime, so a dime, 2 nickels, 4 pennies. A dime, a nickel, and 9 pennies, so we took one of those nickels and broke it apart into the 5 pennies. So that's 10, 15, and then 24. 4 nickels is 20 cents and 4 pennies. 3 nickels is 15. 15 plus 9 is 24. 2 nickels is 10 plus 14. We could just have 24 pennies. We could have a dime, which is 10 cents and 14 pennies, so that's 10 and 14 is 24. Or a nickel, which is 5, plus 19 pennies, which is 24. So if we count those, 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 9 different combinations. Does our answer make sense? Yes, because we made a list that shows us all of the different possibilities and counted that list. Okay, let's go ahead and take a look at the next one and just kind of see. This one we don't have as laid out for us, so this one we have to do a little bit more on our own. Brody has 3 cats. One has a mass of 4,523 grams. One has a mass of 5,012 grams. One has a mass of 4,702 grams. If Brody picks up 2 cats at once, what are the possible total masses that Brody is carrying? So we have 3 cats, and we're going to do this through an organized list. What do we know? Well, we know, I'm going to go ahead and type these in because it'll make it a little bit quicker. Cat number 1 is 4,523 grams. We know that cat number 2 is 5,012 grams. And we know that cat number 3 is 4,702 grams. Let's make that just a little bit bigger there for you. 22, maybe 26. Okay? Yeah. There we go. So we know those 3 things. The first cat is 4,523 grams, the second cat is 5,012 grams, and the third cat is 4,702 grams. Okay, what are we trying to find? The total possible weights. Total possible weights of 2 cats. Okay, so when it comes to actually doing some of the math down here, math, you know, we're going, I'll write out, but for these few I'm going to type it. List the combinations of cats and then add them together. So I'm going to, let's zoom back in on that, sorry. I'm going to bring this down a little bit lower so that I can see it here as well when we try to solve. Boop. So we can, three different. So this is where the organized list comes in. Okay, and I'm going to do this. Okay, so we know that he only has 2 cats. So I can have let's see. Cat number 1 and cat number 2, and that is not any better handwriting. I'm sorry, I'm just going to write with the mouse. So we can have cats number 1 and 2. We can have cats 1 and 3. Or we could have cats 2 and 3. Those are our possible combinations for any cat. So 4,523 add 5,012. Ooh, God, my handwriting. 4,523, and then we're going to add to that 4,702. Remember, the most important part about adding larger numbers like this is just making sure your place values add up. And then for cats 2 and 3, that's 5,012 and 4,702. Okay, now we've got to add all of these together. To save me a little bit of time, I'm going to pause the video, do the math, and then start recording again. So hold on just 1 second, I'll be right back. And I'm back. In no time for you was a couple of seconds for me to do that math. The important part is the learning how to make the list for this, so I don't want to waste my precious 15 minutes of video time doing the addition, because I think you guys know how to do that. So we've got cats number 1 and 2 were 9,535, cats number 1 and 3 were 9,225, and cats 2 and 3 were 9,714. All of those estimate to about 4,000 or 5,000. So when this asks us, does our answers make sense? They're all in between that like 9,000 range, which is about what 4,000 and 5,000 would be if we estimate. Now, my screencast video here can only be 15 minutes long, so we're going to move on to this next page, and we're going to do as many of these examples as we can within that 15 minutes, so you can watch and we can practice together the different ways of making a list. So, we're going to solve these problems, and I've got this little bit of workspace over here that I can use. Okay, so Brianna has 0.16 or 1600ths of a dollar. How many combination of coins could she have? So we want to think at first again, pennies, nickels, dimes, and quarters. Quarters being 0.25 or 2500ths of a dollar, 25 cents. Quarters too big. Okay, so pennies are worth 0.01. Nickels are 0.05. And dimes, remember, are 0.10. So if she can have 16 cents, I've got to figure out all of the different ways I can make 16. So again, I'm just going to kind of pause the video here and then make the list, and then we'll talk over the list when I'm done. So be right back. Alright, so take a look at that list there. We've got a dime, a nickel, and a penny. That's 16 cents. I've got a dime and 6 pennies. 16 cents. 3 nickels, 5, 10, 15, plus 1 penny is 16. 2 nickels plus 6 pennies is 16. 1 nickel plus 11 pennies is 16. Or just 16 pennies. So if we count those, we've got 1, 2, 3, 4, 5, 6 6 different ways that she could. And I know that because of this organized list I've made over here. So the key detail to this is making that organized list for each of these problems. We've got time for maybe 1 or 2 more. There were 3 races at the track meet. The distances were 100 meters long, 800 meters long, and 3,200 meters long. Suppose Lucy ran 2 different races. What are the possible total distances that she ran? Okay, so we've got the 100 and the 800 she could have run. We've got the 100 and the 3,200 she could have run. I'm shortening these, I realize it, so just bear with me. And then we have the 800 and the 3,200 she could have run. So what are the total possible distances? Well, 100 and 800 would be 900. 100 and 3,200 would be 3,300. And 800 and 3,200 would be 4,000. Okay? Keeping this in an organized list like this, almost like a chart, is what makes this easier for me to understand. So what are the total possible distances she could have run? Right there. 900 meters, 3,300 meters, and then 4,000 meters. Okay, let's go ahead and do one more and see what time we're sitting at. Just under 12 minutes right now. Aaron, hey, that's me, has 3,700 milliliters of lemonade in a pitcher. He has 3 cups. Their capacity are 3,200 milliliters, 320 milliliters, 495 milliliters, and 583 milliliters. Suppose Aaron fills the 2 cups. What are the possible capacities of lemonade that he could have left in the pitcher? So Aaron fills 2 cups. So he could fill, we're just going to call this cup 1, cup 2, and cup 3. He could fill cups 1 and 2. He could fill cups 1 and 3. He could fill cups 2 and 3. Okay, I'm going to pause you for just 1 minute to do a bit of math here. I'll be right back. All right, take a look at those numbers there. Cups 1 and 2 are 815 milliliters. Cups 1 and 3 are 803 milliliters. 903. Sorry, I was thinking that didn't sound right. 903 milliliters. And cups 2 and 3 are 1,078 milliliters. So there's my answer, right? No. This is, if we were in class, what I would refer to as one of my favorite no's, because I'm sure somebody would have stopped there. What it asks me is, what are the possible capacities of lemonade that he could have left in the pitcher? Okay, so make sure you look for that final question to make sure you give me the right answer. What we need to do then is subtract the 3 of those from the original 3,700. Be right back. Okay, I've got about 1.5 minutes here to wrap things up, so we're just going to quickly go over this. You see my subtraction there. 3,700 minus 815 is 2,885. The next one is 2,797, and the final one was 2,666. My biggest sets of advice for you when doing these 4 practice problems is, number 1, to make sure you make that list. Whatever it is, make a list of all of the math that you need to do. That would be that 1 and 2, 1 and 3, 2 and 3. Or that would be the, list of all of the possible coins, and then all of the possible ways those coins could be made. So make that list. And then also important, as we did down here with my favorite no, make sure you're answering the question that is being asked. If I would have just given the total for 2 cups, my answer would have been wrong, because what it wanted to know was how much was left in the pitcher after pouring it into the 2 cups. So those are my 2 bits of advice on this. Number 1, make your list so you know what all you need to find. And number 2, double check your question so you know you are answering the correct question. The practice problem will be posted in a link below. If you have any questions on them, please feel free to send it to me, either through the Flipgrid, through email, or whatever. And with that, good luck, and we'll see you next time.